Here is question number 31. A mass m is connected to massless rod of length L and free to rotate in a vertical plane about hind end of rod. If rod is released from horizontal position and mass m collides inelastically at lowest position with identical mass small m as shown in figure, then what will be the maximum height attained by the combined mass? After collision, the masses are stick together. So this question is actually the application of law of conservation of momentum as well as law of conservation of mechanical energy. It requires both. Now, since this mass is released, so its initial velocity will be 0, it gets down and collides with the another mass small m. Both masses are same. Now using the conservation of energy, we can write the mass of block or ball which is attached to the rod exactly before it colliding with the another ball given below. So using the conservation of energy, we can say that net energy initial will be equal to net energy final, where the net final energy is the situation exactly before the collision. Taking this as a reference line, we can have potential energy, that is mg into L, plus kinetic energy 0 because it was released from rest. Finally, it has got to the reference line, so potential energy will be 0, and suppose velocity is v, so kinetic energy is half mv square. After solving, we get the value of v as under root 2gl. So this is the speed of this block exactly before the collision. That is under root 2gl. Now applying the conservation of momentum for the collision. This is the situation before the collision and this is the situation after the collision. They are together moving with combined mass capital V. Before collision, the total momentum was m into under root 2gl, and after collision the total momentum will be total mass, that is 2m, and combined speed capital V. So here from we got the combined speed capital V, that is under root 2gl divided by 2. So the blocks will now move with a combined speed. Now here you are having two blocks, they are moving with speed v. Suppose they get a maximum height right here, which is small h above the reference line. Now applying the conservation of energy, E final or E initial must be equals E final. Initial energy, they are on the reference line, so they will have only kinetic energy, that is half mass is combined 2m, and speed, that is 2gl divided by 4, which must be equal to, finally when they reach at maximum height, their velocity will be nil. So only potential energy they will have, that is mgh. Mass is total 2m, gravity g, height is h. This h we have to calculate now. 2m gets cancelled with 2m. G will be cancelled with this g. 2 will be cancelled with this 2. So ultimately we will get the height, the maximum height where they will reach will be L by 4. So h will be L by 4, and after looking at the options we can say that we have to go with option number 1. Now let us proceed to the next question, that is question number 32. Here is question number 32. An object having kinetic energy 50 joule is moving with linear momentum p equals 3I plus 4j cap kilogram meter per second. The speed of the object will be what? We know very well the expression for kinetic energy is what? Half of m into v square. We can further split up this as half mv into v. So after looking, we can say that we got the expression for kinetic energy Ke as momentum into velocity divided by 2. So ultimately we got the expression for speed v equals 2 times kinetic energy divided by momentum. Let's plug the values of kinetic energy and momentum from the question into the final expression. We get 2 into 50 divided by The magnitude of momentum P we can write exactly from this vector form, that is under root 3 square plus 4 square, 5 kilogram meter per second. So 5 10 times. So the speed of the particle will be given by 2 into 10, that is 20 meter per second. And after looking the options, we can say that option number 4 is absolutely correct. So we will go with option number 4. Now let us proceed to the next question, that is question number 33. Here is question number 33. The tension in the cord connected to the motor is 15,000 Newton and mass of the lift is 1400 kg. If mass m equals 100 kg is inside the lift connected with the massless string as shown in figure, the tension in the string connected with small m will be what? We have to take g equals 10 meter per second square. Now let us first of all calculate the acceleration of lift. Suppose the acceleration of lift is a. So this a acceleration of lift, we can write what? The net force acting on the lift divided by the net mass of lift. Now tension in this string connected with motor is 15,000. Then tension in the string connected with the lift will be 15 plus 15, that is 30,000 Newton. Upward force is 30,000 Newton and net downward force will be the weight of lift as well as weight of this mass suspended inside the lift. So we can write the total force is what? Upward minus downward, that is 30,000 minus of weight of the system, that will be 1400 kg plus 100 kg multiplied by gravity. You will get 1500 into gravity divided by total mass, that is 1500 kg. After solving, we will get the acceleration of lift, that is 10 meter per second square. So the lift is moving with an acceleration 10 meter per second square and it will move in upward direction. Now let us draw the free body diagram for the mass m. Its weight mg acting downward, tension in the string that we have to calculate upward, and the mass is moving with the lift, so its acceleration will be same as lift, that is a. Applying Newton's second law, we get the net force acting on mass m, that is T minus mg, will be m into a. So tension T will be mg plus of ma. Mass is 100, gravity 10. Mass is 100, acceleration you have calculated for the lift 10. So we got the tension in the string connected with the block inside the lift will be 2000 Newton. So after looking at the options, we can say that we have to go with option number 3, which is absolutely correct. Now let us proceed to the next question, that is question number 34. Here is question number 34. A pump of power P ejects m kg water per second through a horizontal pipe. If power of pump is doubled, then using the same pipe, amount of water ejected in 1 second will be what? So here, the question is talking about the rate of ejection of water with respect to time, that is dm by dt. Initially, the rate of flow of water is m. So first of all, let us find out the expression for dm by dt. dm by dt will be what? ddt of what is mass? Mass is volume into density, and volume is area A. Length traveled by the water in small time interval dt is x, density is rho. So we got the expression dm by dt as A rho multiplied by dx by dt, that is v. And here the rate of ejection given in the question, that is m. Equation number 1. Now we know very well that the power delivered for the flow of water in this cases will be what? V cube multiplied by density multiplied by area of cross section of the pipe. So from here we can say that the speed is directly proportional to p to the power 1 by 3. If we change the power, speed will also be changed. Now if we double the power, let's say how the speed is changing. The new speed is v dash, power is 2p to the power 1 by 3. Taking the ratios, we get v dash equals 2 to the power 1 by 3 times v. Now the new rate of flow of ejection of water will be given by m dash, that is A times rho times V dash, which is further m dash equals A rho multiplied by the value of V dash is what? 2 to the power 1 by 3 times V. So m dash, that is new rate of flow of water, the rate of ejection of water, or you can say dm by dt, will be A rho V is equals m. So 2 to the power 1 by 3 multiplied by m. So this is our final answer, and after looking at the options we can say that the rate of flow of water will be option number 3, that is 2 to the power 1 by 3 mkg. So we'll proceed with option number 3. Now let us proceed to the next question, that is question number 35. Here is question number 35. Forces of equal magnitude of 0.5 Newton are acting on a square plate of side root 2 meter and mass is 1 kg as shown in figure. The net torque acting on the square plate about center O will be what? Now these all forces are producing a rotational effect in same direction, that is anti-clockwise direction. So that's why their torque will be added. Torque will also be in same direction. That's why the net torque will be addition of all the torques. So tau will be equal to tau 1 plus tau 2 plus tau 3 plus tau 4, where tau is the notation for torque. Forces are equal and the distance between force and point about which we are calculating the torque is also equal. So we can write tau for everyone. So the net torque will be equal to 4 times torque due to any force. So tau equals 4 times torque due to any force. Just pick any one force. We are picking the upper one. Force is 0.5 Newton multiplied by, what is the separation? See, if this angle is 45 degree, and it is certainly 45 for the square, the side is root 2, then the distance r here will be what? Root 2 cos 45, which ultimately gives you 1. So let us plug in the value 1 here. We will get 4 into 0.5, that is 2 Newton meter. So the net torque acting on the square plate will be given by 2 Newton meter, and after looking at the options we can say that option number 4 is absolutely correct. So we will go with option number 4. Now let us proceed to the next question, that is question number 36.